This is the one-way ANOVA video on the intuition behind the ANOVA table. I'm going to show you three sets of box plots, each of which summarizes the outcomes for patients receiving one of three drugs. I think you'll agree that this plot indicates statistically significant differences between the three groups. On the other hand, this plot illustrates data without significant differences. And this plot illustrates something in between. Well, how were you able to draw these conclusions? Your eye instinctively compared two constructs, the level of signal and the level of noise. In one-way ANOVA, the signal is derived from the difference between the group means. Visually, the greater the vertical distances between these group means, the greater the signal. The noise is derived from the level of variability within the groups. Visually, the wider the box plots, the greater the level of noise. What the ANOVA table does is to provide a succinct summary of the calculations involving signal and noise. Depending upon the statistical software, the signal line and noise line can be labeled in various fashions. Often the signal line is labeled model, and the noise line is labeled error. The signal has a numerator and a denominator. The numerator is the model sum of squares, and the denominator is the model degrees of freedom. And for the purposes of this video, all these terms will remain undefined. As the distance between the group means increases, so does the model sum of squares, and thus so does the signal. The noise also has a numerator and a denominator. The numerator is the error sum of squares, and the denominator is the error degrees of freedom. As the variability of the data within groups increases, so does the error sum of squares, and thus so does the noise. Sometimes the ANOVA table has a third line labeled total. After calculating the signal and the noise, the f-test divides the signal by the noise. The larger the value of this f-statistic, essentially the larger the signal-to-noise ratio, the lower the p-value that R will calculate for you. Another video covers the details of this calculation.